Hello, guys. Welcome back to webinar 3, where we'll be talking about our tool registration, tool setup, and a competition run for design phase 1. We're going to show you an example run in how we are going to take a peripheral in design phase 1, how we are going to attach it to our module, and how we are going to run PPA analysis on it. All right. Well, let's start with a recap of what we've covered so far. First, what the competition structure is. So we've been going on about how we are going to design this as a 16-week journey where you don't have to put too much time all the time, but you can take your time with it, evolve, and apply your own design in your own time. We have phase 1 with base design expansion, of which we are running a demonstration today, and phase 2, which is design evaluation and PPA optimization, which is going to be a month later in February. We have phase 3, which is security evaluation and threat mitigation, which is in March. And then we have phase 4, that is the final netlist to chip tapeout, which is going to be in April. Moving ahead. So we've talked about the key technologies in our last video. So what are our key technologies here? It's going to be the RISC-V, which is the open source architecture we will be building upon. It is a small microcontroller CPU, which will help drive the kind of peripheral tools we would like to attach to it. For example, an AI accelerator, any kind of PWM application, or an enhancement to the tool. Next, we'll be using AI specifically to help develop the code and help give us a better flow with the overall process. Third, we are going to work on EDA tools where the commercial and open source software is a path you can choose. Next, what's the challenge? We are going to be customizing a RISC-V core here. Our project is a core-based implementation where we are going to be taking a RISC-V core. We're not going to be touching the CPU or any of its Verilog files. We're just going to use it as reference, and we'll be having an additional peripheral.v file, which is a Verilog file where we will be designing our custom module. And we will also have a TT wrapper.v file, which is going to be the top module to connect our peripheral module to the CPU module, which is the RISC-V module. Our primary task here is to just modify the peripheral V and extend it with new customer functionality. You'll be focusing on modifying your code and optimizing the code only, not the processor core provided to all teams. So the module or the peripheral, what is it? We are using a bite-size full peripheral template where you have 32-bit and 4 bytes, which is the full width of the CPU. Here you can design, the complexity here mentioned is high, doesn't mean that it's going to be pretty complex where you can run into errors. It is the module and the interface is very simple where you just need to put in your ideas of your own design, like a Verilog file or a accelerator or an encryption engine or a math coprocessor. You can use it from a lower complexity to all the way to a high complexity, which gives you a wide range to make any kind of a design you want based on what your interest is. Okay, moving forward, the base system. So what are you going to be starting with, or what will you be provided is what we are going to show you today, how we are going to set up the tools first and how we are going to be attaching our design phase 1 run. You'll be given a synthesizable Verilog RTL code, a verification suite, which has all the verification test benches, documentations, which is the full spec of the code design on our GitHub repository, and the tooling environment, which is access to Cadence tools, Synopsys tools, and open source tools. For now, we are going to demonstrate how we can install the open source tools since they are easily available on the internet, and you just need to run a few commands to install them. Moving ahead. So Let's start with how we are going to use. Suppose you have a Linux operating system or a Windows operating system or a Mac operating system. Now, each time your operation or your run or the commands you give is going to be different and varying from not much from Windows subsystem for Linux, which is WSL, a platform for Windows Play OS, or Linux. It's just going to be like a small container which has Ubuntu software in it where you can run your Linux tests. Whereas it comes to Linux, all of these softwares were originally built and developed for a Linux operating software, so the commands here will be easily applicable to a Linux software too. Coming to a Mac OS, we will be shortly uploading another video for how we can use or how to install it, but it's going to be a different setup using brew and install other than WSL and Linux. Let's take a look at how we can install it first. So first we install the WSL software, which is the container for where we want to install our tool setup using the following commands. And this is only for a Windows software. You don't need it on Linux or you don't need it on Mac OS. So now here, once you install your Ubuntu software, you want to create a profile as the same as you have a Windows profile when you log into your desktop. So here you're asked to create a user account for your Unix system and a password. So after you're done with this, you just simply need to run WSL. As we see here, we've already entered the Linux system software, which is Harry at the rate whatever your system PC is. Other than that, you just need to use WSL to simply log into your Linux software or Linux system. Next, we are going to focus on how we are going to run or how we are going to create our project directory and install the required tools necessary to complete our project run. As you see, you use make mkdir, which is make directory. You create a directory called AI-HDL. CD is change directory to that particular location where you enter that location. And now we are going to use git clone, which is a function to clone the Verilog files from the internet, which we need to run from the TinyQE software, which TinyQE page, which you can see here, to our local setup. As you see, it is done here. And next, we are done. So this is how you set up your project directory, install the files required, and next we are going to move it to the tool installation. So let's start with what Yosys tool installation is and what it's required for. Yosys tool is a tool required for synthesizing a design, and then you use Verilator in conjunction with it to verify your design is correct or not. And you can also use it as a process to get your area estimation through synthesis. You, in this process, at this stage, after Yosys run, you might not get your power results or your performance results, which you will get after running a CTS full plan. So simply to install Yosys, we create another directory. We come out to our local directory, which is AI-HDL. And as you can see, we have the GitHub page pulled here, and they have a simple code which makes it easier. Simply copy that line and paste it, and you're cloning the Yosys repository or the local files necessary to build the tool. Once that's done, you see here on the left, we are copying a command which is installing all the prerequisites for building Yosys. Think of it like a conditions for an environment to set up its tools or what other additional tools it requires to run. Here we install all those necessary dependencies for the tools to work. As you see, it takes some time while you're installing these processes, depending on how your internet connection is and how fast of a PC you have. It might take somewhere from 5 minutes to 30 minutes. I would say Yosys is a heavy package where it requires almost 10 to 15 minutes for installation. As we see, we just created and installed the prerequisites we require. Now we are gonna go ahead. Oops. Yeah. So now we are going to go ahead and install Yosys into our local directory simply by implementing one simple code. But before that, here we are copying make.config clang. Now what that command is it sets what environment you want to use to install the tool necessary. Now that that's set, you simply type in sudo make install, which will simply build using the local tools you've downloaded from the repository onto your local PC. And this process itself takes 10 to 15 minutes. So we can move ahead a bit. Now, now that you're done, we just, right, one moment. So now that you're done, you simply type make test to run a test to verify whether the tools you've installed is properly installed or not, or all the setups, all the verification passes are done. After you're done with the tests, you simply type in /Yosys or Yosys to open up your Yosys terminal. Here you can also check what version you're using by simply typing Yosys dash dash version to see if it is the latest Yosys tool version you're using or not. And just by typing Yosys, you enter Yosys. With that, we are done with how we are going to install Yosys. Next, we're going to move on to the next tool. So Verilator. Verilator again works in conjunction with Yosys as a verification tool to verify your test bench alongside your Verilog codes that you just synthesized and the netlists generated from it. So now I would say Verilator is a quick install. It doesn't take too much time. All you need to do is you can go to the Verilator website and simply clone their repository to your local directory. And then you, every time you need to build, you just type in the following commands. If you are using bash, you can use unset. And for CSH, you can use unset even environment Verilator root, which will basically set the environment for what for the tool you're going to install, and then install the tool using auto configure and sudo make install. Next, once you're done, you just need to click Verilator install dash dash version. Sometimes it cannot find it and it'll give you a simple command to run it again and install the tools. By running sudo apt install Verilator, it again rebuilds the tools and completes the verification this time and installation. You can now click verilator.version to check if it is installed onto your local directory or not, which in this case has been done. Next. Klayout. So what do we use Klayout for now? Klayout is a tool where you draw your design. Suppose you've used Yosys to synthesize your Verilog files and see if it is verifying or not. In Klayout, you pull it out as a layout and you adjust, you create floor planning and CTS, and you add IO pads and pins and make sure it passes DRC and LVS runs through Klayout. Now again, most of these tools other than OpenLane run on a local repository, whereas OpenLane uses Docker to run on a separate your OpenLane dedicated server. So again, we follow the same process as we did for Verilator, where we use, in this case, I defined a proper installation tool method for Klayout. So what do? I use AI's help. And AI is pretty reliable these days to help you with tool installation, fixing your code. So once you simply run the following commands to install the dependencies first. Next, we are gonna clone the GitHub repository. So once that's done, now we clone the GitHub repository and we open the CDA Klayout directory and type in dot slash build sh. Now what that means is most tools come with their own build script to install everything in the required location. All you need to do is just run that via Python or in your local Linux server. Now again, S- Scanning installation, it says this installation has been done, but it is unable to find a qmake tool to install the path. Now again, when we type klayout.version, it couldn't install. So it gave us another line called sudo apt install klayout, which will help install it easier. Now that we are running that command, at the end of this, you can simply type in klayout to check out your klayout. Now again, Klayout, like the previous tools, is not a terminal viewer, but instead it is a separate application where you can open your design and edit. As you see, simply by running Klayout, Klayout has started and has opened. As you see, this is the Klayout window where you will start designing and loading your tools via file and everything. This confirms that the Klayout tool has installed properly. Now we are going to install OpenROAD. Now what is OpenROAD? Now that you used Klayout, think of this like a tool flow where first you synthesize, then you view your layout and you edit your layout, and then you move next to the next process, which is running CTS, floor plan, and connecting all the IO pins. Whereas in Layout, you size and make sure it is not causing any DRC errors or LVS errors. In Again, DRC is a design rule check, which is has a certain set of rules in the Klayout app, which will always pull up as you see. But LVS again is a comparison between your layout and your schematic, if they are matching or not, even after it you clear all those DRC errors. So that's why once you clear your DRC errors, you move ahead to LVS. And now once you're done with LVS, you are stick with creating the floor plan, giving cells, creating IO pins and pads, and that all of that is gonna be run using OpenROAD. So let's see how we install OpenROAD. Again, we are gonna use the same process since we are gonna git clone. Now we have cloned the OpenROAD into our local directory using the following command. So Here you can install OpenROAD in two ways. You can use a Docker method or you can use a local installation. I would say we can go ahead with the local installation since the file size isn't too much and it just requires a few lines of code to set it up. Right now, as we see, we are cloning the OpenROAD into our local repository, which is still going on. Since it is a file, it takes a bit of time. You could say 5 to 10 minutes, so you'll have to be patient with it. Sometimes you might notice if you don't have a stable internet connection, the installation or the cloning process might stop midway, and then you have to clean it again and re-clone it into your local repository. Now that that's done, we are going to go ahead and install the local dependencies, which is over here. These dependencies are not required if you want to build via Docker, which is a local server. But if you want to build it locally, you need to follow this particular path where you install the dependencies first. It takes some time where it checks, and then you can build OpenROAD using the following command below. And with that, you're done building it. As you see here, I've already so you see a status of what tools you have, what packages are required. These are all prerequisite packages required as they have been installed and the required latest ones have been updated. Next, as you see here, you use etc/build.sh, which is the build script for OpenROAD. And this again, the build takes another 5 to 10 minutes. You don't need internet connection for this, so you just need to wait for it to build completely. So now that here, it also tests whether the build is properly done or not. And next, we see how we start our Git our OpenROAD. All right. Now, sometimes the same command OpenROAD dash dash version may not work out because not all tools are installed in the same method as it is, as we've seen in the previous versions. But you just need to go to the right location where the tool application is and just type in to start the command to start the application and it should start up. As you see here, it is located within OpenROAD slash OpenROAD, which is another file within the repository local directory. And then you go to, oh, I'm sorry, you go to build, which is over here, OpenROAD slash build slash bin, where you have our OpenROAD application. Now, the color also makes a difference where white color is a file, blue colors are folders where you have another applications or files within them, and green color over here, which is OpenROAD, is an application. Now, simply type in /OpenROAD to start your OpenROAD application, and once you're done, you can simply start putting your files and synthesizing and getting your CTS done. Now that this is done, we are gonna go to OpenLane. So what is OpenLane now? Now that we've talked about all these four tools, OpenLane is a tool that is sort of a wrapper and connecting all of the other tools into one particular bin. So it connects Yosys, it connects Verilator, and it connects Klayout and OpenROAD all in one flow to just give it a proper RTL to GDS2 flow where you can just submit your Verilog files and you get your GDS2 end results along with your PPA matrix. So this tool is what we'll be using to get our PPA analysis. And this is the tool which we'll be most likely using to run operations on through design phase 1, 2, and 4. For design phase 3, which is a security round, the tools we are going to use are different. Now, OpenLane. Let us check how we are going to install OpenLane. We have the OpenLane documentation. You just need to go to Google and type in OpenLane, find the location, and you can immediately get started with installing it. So again, we come back to our local repository here. We go to Windows 10 to check. Again, no. Docker, as I mentioned previously, is a package we are going to be using right now to see if it is running. What you need to do for a WSL application or for a Windows user is you can simply install Docker desktop via the Microsoft Store. So you just need to go onto your Microsoft Store, search for Docker desktop, install it, and run the following commands. And you want to check the Docker installation too. So type in Docker run hello world once you're done with the installing the prerequisite packages to support the tool. Again, these prerequisites are different. They're not to install the full tool, but to support what kind of waveforms we want to view using Docker. So now, once I put in docker dash hello run, it gives us a message saying that your installation appears to be working correctly. To generate this message, Docker took the following methods. Once you've done and verified your Docker installation, now we are going to go ahead and download OpenLane using the Open. We are going to clone OpenLane repositories to our local directory, and then we are going to run the necessary commands to ensure its functionality and install it. So no, you can also see that it is collecting all kinds of packages and it is also collecting certain PDKs, which is Sky 130A, which is the particular PDK we are going to be using in this design with Cadence and other tools, open source tools and commercial tools too. As we see this going on, we can move ahead as this installation sometimes. So again, keep in mind that these packages are heavy packages and might require some time. With a fast connection, it might take a faster time, but with a slow connection, it might take some more longer time. So you need to be patient with this particular step. So now that that's done, it starts running a test automatically because of the commands we've done previously. We've kind of added all the commands together and ran it together at the same time. Here we can see it is running test to check if the OpenLane Docker and the local server are connected properly, the toolpaths are connected properly, all the PDKs are in place, and it just verifies whether there is any error with the whole run. If it isn't, you'll see a following output said basic test passed. As you see here, but just by looking at this, we can see that the basic test has passed. Now, if we want to check that, we can go into OpenLane and run it. We simply type in make mount to enter the Docker session. And here we are currently going to we're going to check a SPM module using Klayout to check how the chip designs. So just simply put in the following commands one after another without any space. The slash here means it is a continuation of the next line, even though it's in the next line. Once you've done that, the setup is loaded up here in a Klayout visual, and then you can see how your layers are, how you're going to be dealing with this in round 4. But this is a visual of testing that your OpenROAD is finally working. Now that that's done, we can go ahead to talk about our DP1 example and how our project run is going to be looking like. Like I've already explained at the start of the meeting, we can go ahead with this by simply just modifying one peripheral Verilog file. And you just need to give the top module's name or your module's name from the peripheral.v to your TT wrapper, and it will automatically connect to your CPU core, which is the RISC-V core in this example. Let us move ahead and see it. So in this video, we will be demonstrating a project example run. Here, we've already have a peripheral. Here we have, as we see here, we have our tools already installed and necessary for the whole run. And we've installed TinyQV and TinyQV Byte peripheral to show you a demonstration. Now, first, we are going to create our own small repository for Yosys' synthesis part. So, DP phase one, we can divide it into two parts, where the first part is you're running a synthesis and verifying whether the created peripheral V will synthesize or not and runs functionally. The second part is you're gonna use OpenLane to generate its PP results and automatically run how much area it is consuming, how much power it's consuming, and what the performance is. So here, may we create another directory called dp1 and open it. Next, we copy our particular files we need from our tinyqv. So here, as you see, we have a CPU, ICE Fun, Peri, Pico ICE, Test, and Verify. So ICE Fun and Pico ICE are verification runs of previous runs. CPU and Peri are the main files that we require. Or to be more precise, CPU has the exact Verilog files, which is the RISC-V Verilog modules. Let's take a look ahead and open the CPU file. So here again, I'm gonna give a command which is useful to copy your files from the particular CPU file to your local directory, which is dp1. Simply run this command in the CPU directory to copy all these files in this folder to your folder. Once it is run, you can simply go to your dp1, or first we're gonna copy all the other files here. Now we're gonna go into the test files and copy all the files here. Next, we are gonna come to the verify and copy all the files there. Now that that's done, we are gonna go back to our dp1 directory and verify we have all those files. Before that, we are also gonna copy. So from tinyqv, we haven't copied peripheral as you've seen because the peripheral over there are other peripherals that we are not require. Yeah, they are attachments of peripheral and examples of peripheral that you can take a look at, but we're not gonna be running our peripheral design through those. We are gonna use the tinyqv byte peripheral template or the full peripheral template to attach our peripheral.p file and run it with the TT wrapper. Now here, as you see, we're running a few commands to copy all the file directories into our local directory. Now that we are done copying from this SRC, which has the source files for the Verilog code and the test harnesses in the same file, we come to the test bin and copy all those files too. And now we return to our dp1 file. Here in the byte peripheral folder are the Verilog files which we'll be modifying throughout the competition, as I've said earlier. And yeah, as you see here, the peripheral.v test harness is a folder and TT wrapper All these files are the only files that you'll be requiring to make edits to and update your test benches in the test harness, your peripheral, your Verilog module in your design, peripheral.v. And as you see here, we have a list of the files will be required to synthesize and run test zone. So I'm going to pause here and let you guys take a look at what kind of files we have. We have the CPU files for it. We have the test bench files for all the CPU codes, and we have the test bench files for our peripheral design. Our TT wrapper is over here, and our peripheral design is over here. Oh, wait. Yeah, right over here. Now, after that's done, you might have a question. Okay, we've installed it and we're moving forward, but how do I run this? I have no clue about this. That's where AI comes in hand. Here you can take the help of AI to just take a log, a screenshot of your command prompt log and paste it into AI to ask for help. As we can see here, let me show you what I do or how we can go ahead with. I simply copy my design folder, the files I have, and paste it, and I give it a prompt. I want to run synthesis using Yosys. What it does is now it gives me certain methods where it can give me various options or it can give me a script code to run these commands. Yep. So it takes some time. You already know how AI works, but as you see, our output here is a synthesis file. So now what is the synth.ys? The synth.ys is a Yosys script which you can use and develop to run particular Yosys commands. So simply you just need to use yosys.synthys to run all these commands which are in the Yosys format. Oops, sorry about that. Yeah, simply you need to run all these Yosys commands. And as you can see here, yeah, I did a pretty good job at collecting what my system verilog files are, what my Verilog files are. Here the order doesn't matter because any kind of order, the Yosys automatically creates a top to bottom approach with the top module in hand. So all you need to do is just write down a list of the files you have and just give it the command. As you see here, we are using Nano to create our syn.ys file, and we're going to copy all of this here. As you see, we've had the Verilog files, and as we go down here, we also have. So also, I would like to for here we follow script approach because it helps dealing with problems easier. And suppose you have an error, all you need to do is kind of modify the script to ys file rather than going through all those commands back to the top and editing it one by one. Here this is just a simple flow and it is clean to simply give you out your net list. Other than that, I would like you guys to take a clear note where when you're using AI, please do not just randomly copy content, but also read through what there is, saying like, suppose here, replace TT-UM example with your actual top module name, which we only know is within the TT/wrapper.v. So if we move forward, here I will show you that I am going back to I'm going back to open our TT.wrapper. And here we see that the peripheral name or the module name is TTUM/TQV/peripheral/harness. All you need to do is simply copy this and attach it here. And it will automatically connect that as the top module and arrange all the files in the necessary format. Once you've done that, you simply run or execute the command as we show here. Now, simply write yosys space synth.ys and it runs automatically. So you want to know if your Yosys has ran clearly or not. Here, as you see, you will see a set of your last version or last Run is going to be number 25, which is generating the representation of the design. And then you're going to see a list of how many warnings you had. You have two unique warnings here and seven total, but no errors, which means the synthesis is done overall. End of script, you have time spent here and how much of uh oh, you can also see how much time it spent to read the Verilog file and how much time it had to actually run an operation to synthesize it. Now, now that that's done, you can say that one half of your design is done. You can clearly say that your peripheral design is synthesizable, it is working, and now you can go ahead with generating its PPA results. If you have your peripheral or your module design ready, after that you can just run PPA analysis to go ahead, or you can go back, change, and you have enough plenty time to update it and verify it and change it as you please. Next, now that we are done with this, we move ahead to using OpenLane to generate our PPA results. Mhm. Similarly, now we use AI again to give it a prompt and see how can we run a PPA analysis using OpenLane. Before that, we also need to do one specific thing. Since your OpenLane runs in a Docker session, which is a local container, you need to have all of your design files, which is your DP1 directory, which has all of our Verilog modules, into the OpenLane's local design directory so that it can connect automatically with the container to run it flawlessly, as you see here. So now that that's done, we simply enter the directory again using cd. And you can see here, we have our dp/1 and SPM, which was our previous run. So SPM was a pre-built module and you just had to run a certain command to for it to generate. But for DP1, how do we generate it? First, we want to enter our open lane, which is make mount, and then we run this particular run. Once you enter, we also need to configure our so yeah, before you enter, I also want to specify that you have to configure your particular Verilog files and list down what Verilog files you have into. Similarly, like Yosys is synth.ys, OpenLane uses config.tcl to run a flawless design. And it has all the outputs or all the commands necessary to point it out to the required direction and what exactly we want to do with it. So we are going to open up our config.tcl first. Oh, it's not going to be config.tcl, it's going to be config.json, which is a Python file. Here you see again we've given AI the required files and it just immediately point out us to improve or apply these to the config.json. Simply copy these files. Also cross-check your Verilog codes before you send because sometimes it can also send something like your list of files. Once you're done copying all your Verilog files in the required folder, you also want to copy your design name and top module to specify what is going to be the top wrapper for the design. Here our top module again is the peripheral harness. And now simply once we're done with configuring or writing all those, we simply enter make mount and enter open lane and simply run the following command, which is dot slash flow dot tcl, and it points us to which design are we going. Design DP1 is the design we are running right now, or DP/1. And once that's done, you simply have to wait and see. You might run into a few errors here, which again, with the help of AI, you go back to it, you give it the errors, you ask it what do I do here, and it helps you out with that flow. But here again at the end, you can see we have a success and that the flow is complete. We do have 874 warnings, but no errors. And the current core area is too small for the power grid settings chosen. So the power grid can be, again, these are stuff you can also optimize down the line. This information, the warnings here, can be useful. So do not neglect these, which can be used for round two, which is your optimizing and how you want to optimize your design. Once you're done, you have a clue of which areas you want to optimize or what are specific problems you have with your current design and how to better create a better design. Now that that's done, we can simply exit out of OpenLane and we'll show you where we can find the PPA metrics. Because there's a PPA metric folder and it has the CSV or an Excel sheet where you can see all your results. So again, we go into designs and then we go into a DP1. Previously, inside DP1, we had nothing except for our Verilog files. But now that we are done with the run, we have a run folder and we have a specific run of which run we made with specific time. You simply want to enter it and enter reports. There you'd find a particular file called metrics.csv. Now this file might look like gibberish, but it has actual points. So I'm going to show you where we can find. So again, we're going to take a break here. Since we cannot view the CSV file properly on terminal, I'm going to show how you can come to your Windows file viewer and go to the particular location to find what exactly you want to view. So here you can go back to Linux, enter Ubuntu, go to home, and then you enter your profile. Here, you know that you have your AI-HDL local repository. This is all our tools. We entered OpenLane, designs, DP1, runs, and then in runs, we go to our logs. In reports, you see here we have our metrics. And here, if you want to clearly understand even more what the process was, each of these files has another report or metrics of what the power was after each process, what the area was after each process, is there any development in the slack time? All of that is recorded. So I would say go take a look at those reports, take a look at all those reports in detail, and you will get a clear idea of what your design is looking like. Or you can also simply upload it to AI to help understand it better. Here I'm gonna mark down what exactly are we looking for in your design. And so we're gonna look at what your final utilization rate is like. There are no LBS errors or CVA DRC errors, which is good. Here at the end, you see your total cells, total number of cells, and your core area, which is 16,493 micrometers. So again, this is important. And then here you have the power, typical. All of this from typical is the required results you need to know what your power is. It contains your internal power, your switching power, and your leakage power. And with that, you can find other stuff also. The critical path and your worst slack, which is WNS and TNS. Worst negative slack and true negative slack, which is here. So these together contain the information for your PPA, which is your power, performance for your slack timing, and area, which is the core area. With this, we can conclude our design phase run one. So as you can see, it doesn't take too much time for you to run this out, but it is a simpler and easier process to do this. All right. With that, we can conclude that this is what our design phase example one run is going to be looking like. Now, now that we are done with our final webinar, we can look at what our roadmap looks like. So our design phase one starts with Jan 15th, and then we'll have a milestone one where we'll be reviewing your designs and giving you updates on Jan 29th. And then a week later, we'll be giving you a date for the final review and evaluation right before phase two. And then we move ahead to phase two. And similarly, We go through phase two, milestone two, phase three, milestone three. And now I can, Professor, would you like to take over?
No, I just wanted to thank you, Harish, for going over all the details, and I really appreciate all the information you gave our participants. And of course, this recording will be available after the webinar is over on the website of AI-HDL, and also we'll be releasing it as a resource in the Discord channel. So if you're not part of the Discord channel, I highly encourage you to join the Discord, where we put all this information and share more resources with you. And what Harish was presenting was just an example, a demonstration of how you can get started come January. So when the competition starts, I wanted all of you to have at least a starting point, and be able to understand what's going on and how you can complete your first design phase. Considering that January still a lot of folks might have exams, a lot of folks might not start the semester right, right at the beginning. There's holiday season and everything. That's why we start in January 15th. In the meantime, I encourage you to start getting the installations ready, so that when the competition starts, you're focused on the design challenge itself. And the addition or the expansion for design phase one that Harish was demonstrating was just a simple addition. You can be creative. You can come up with more creative ideas and additions that you can provide. And one thing that I can, um, share this based on your creativity, based on the complexity of your design, you will get a higher score if your design is functional and it's optimized and so on. So, um, really go out and explore and try to do cool things because that's the whole goal of this competition. We want to, you know, put you in this competition to do amazing designs at the end. So um, don't be afraid to take risks and explore because that's how you learn and grow in this area of chip design. Continue, Harish, please, and finish the slide deck. And once we're done with the slide deck, we'll open the floor for questioning for students.
Yeah, Professor, we're done with the slide deck. Now we can just go ahead and talk about questions. People can submit their questions in the Q&A panel.
Yeah, so I have the chat open. So if you have any questions that you want to ask, you put it in the chat. We'll go over the questions. And
And we can
just
have
a
any kinds
reminder.
of questions, questions about the competition run, what your timings are going to be, questions about the technical tools or how you want to design stuff, any kinds of questions.
And keep in mind the registration is closing tomorrow, and there's no extension of that. So if anyone, your friends that are interested in the competition, make sure that they're registered by tomorrow. So there's a question about who is going to be your mentor. So that information is coming up in the coming week. So once the registration is finalized tomorrow, we'll be going over all the registrations and um, organize the teams, and we'll assign a mentor to each team. And you will know who will be the mentor assigned to you after technically next week, before the competition starts. Any other questions? Please feel free to put in the chat. So the teaming hasn't been performed yet. So if you already had a team, so if you registered with a team, um, there was a prompt in the registration that you could put the name of your other teammates. So if you have done that, we can pair you with with your team. If you do not have a team, you registered as an individual. Next week, our plan is to release the teams, and one thing that we are considering is teams are going to be within the same institution, within the same grade level. So if you're an undergraduate student, you'll be teamed with undergraduate from your institution. If you're a grad student, you'll be teamed with grad students from your institution. I already did registration once. Do I need to do it again? No, if you've registered, um, you're clear. You have probably not received the confirmation because we are working, we're waiting for the registration to close, and then we'll send out the assignments to the teams and confirmation for the registration. So if you've filled out the form, no worries, you're registered. You don't need to do it again.
And also, everyone will receive another verification that your registration was received with your formal teams that you've been assigned to.
Correct. So, could I verify my registration was received? So, if you filled out the form, it's recorded. So, we received it. You don't have to worry about that. What is the proper complexity of an example peripheral, something like ISP, or is more complex, encouraged, and realistic, given the design phase isn't very long? Exactly. So, uh, of course, keep in mind large language models or AI tools that you're going to be using, as designs get more complex, they might actually start giving you more problems. So there's the sweet spot. So you cannot pick a big um, peripheral to add because the limitations of the context and of course if you're using the free version of these large language models, there's some limitations also that these tools add. So we don't expect you to do a huge and complex peripheral example. However, I want you all to be creative and come up with really cool ideas, and you can also brainstorm with AI tools to what could be a good peripheral to add. Of course, the creativity we don't want to limit here. We want to give you the flexibility to pick the design that you are excited about. I hope that answers. Anything to add, Harish?
No, yeah, I would say start with the sweet spot because AI again is unpredictable, but you're also encouraged to go for complex if you can get it right.
Do we need to show our LLM prompts at every check, or is this something we do at the end? So for each design phase, we would like you to have a submission, which where you tag this is design phase one submission. And yes, for each submission, we do need to have your LLM prompts. This way, we can help you better. If your design has issues, we can help you better. The mentors can engage with you better. And also, down the line, if there's any issues coming up in the future, having those prompts going to help us understand how we can help you get solution to your problem. So, yes, the answer to your question.
Also, I would like to add, Professor, that with your LLM prompts also matters the quality of the prompt document you're sending because it's also a scoring criteria.
Yes.
Just one member can register for everyone, Professor.
Yeah. So, I mean, we recommend everybody to register. And if you have a team, you can put the t name of your team members. Um, that way we have all the information because we do have other questions in the registration form that we would like everybody, every participants to answer those questions. So I believe we do need every team member to have a registration, and then there's a spot that you can put the name of your team members, so you can just put it in there. You
I
can,
can,
I think, Harish, you can add to this, but you
yes.
can, if you have any questions about if their peripheral is good or not, you can always reach out to the mentors. and then
Oh, no, I think
have
he's
the
asking
conversation.
that whether we will approve their peripheral concept before they start implementing it.
No, I don't think we need approval.
Yeah,
Although if you're concerned, if you're not sure, you can discuss
during
it
the
with the
milestone
mentor.
one, we will be taking a look at your designs to give you or give you advice on your design.
Mhm.
Yes.
So you do not need prior approval to start implementing your peripheral. However, if you're not sure, you can definitely reach out to the mentors and ask questions. One more question. Do I need any knowledge about deep learning or machine learning? No, we're not really expecting you to have any knowledge of deep learning, machine learning. You're not necessarily implementing the AI that you're using. You're using AI to design a hardware. So it's more of like application rather than designing an AI from scratch. So you don't need your general knowledge of AI and large language models like ChatGPT or Gemini and Claude Code. This would be helpful enough. So, any other questions? Where can we find the scoring rubric? So the scoring rubric was discussed in detail in what I think webinar one or two, Harish, right? Which
I
one
think
was
it
it?
was webinar two, Professor.
Webinar two. So you can watch the webinar two video, and also the slide deck is available in the Discord channel. So all the details are mentioned there. So I refer you to those resources for more information regarding the rubric. Thanks for these questions, by the way. I appreciate all of you guys that are engaging with us and asking questions. These are good questions. Definitely helping with clarifying things. Where can we find the scoring rubric? That's the last question that I addressed. And hopefully we're going to add the frequently asked questions to the website as well so that you know where to find the answers. So that's what one of the team members here, Virmani, is working on to help gather all the questions and put together a FAQ so that we can have all these questions answered in the Discord and on the website. So you have it available at your fingertips. Any other questions, guys? And I really appreciate all of you who are participating and joining this session. And hopefully more folks can watch the video recording, those who were not able to attend this at this time. Considering that this is a global competition, we have participants from all over the world. It could be difficult some time zones to attend this webinars live. So I appreciate if you're watching this video afterwards. And thanks for joining us and participating in this competition. I don't see any other questions, so we'll give it some time. Yeah, there's one more. How do we know who become our mentor, our email sent out? So this was the question I answered earlier. So the mentorship is not set yet. The teams are not finalized yet. So we still have one day till the registration closes tomorrow. Our plan is over the weekend and early next week. We're finalizing the teams, and we'll be sending a confirmation email to all the participants and providing details of who is your team members and who will be your mentor. So that information will look out for that information is coming within the next 2 weeks before the end of the year. And then once you have that information, if you have any questions, feel free to ask us via Discord channel and feel free to send us a message as well in the Discord that we can address. So hopefully that is answered now. Some people were able to join because they were logged out while trying to log in the meeting. Sorry to hear that. I'm not sure what the difficulty there is with Zoom, but thanks for letting us know. We'll look into it and see what's going on and see if we can fix it for future um, so that we don't run into this issue. I'm currently using a very old laptop from 2017. Is it possible to run all the? Yes, it is. So you don't need, so your computer need doesn't need to be the top of the line computer. So let me tell you, actually, this is like a good question that I appreciate you asking. So you don't need the top of the line computer to participate in this competition. Like almost all the stuff that we are doing is going to be on the cloud or using resources that are on GitHub. So you don't necessarily need to have the best computer to run the tools. Although having a better computer might make things a bit faster, but that doesn't mean that you cannot participate. So do not worry about that at all. Anything to add, Harish?
No, Professor. Since all of these softwares are legacy softwares, which means they've been developed since the early 2000s, I think your laptop would be more than enough and sufficient to run these tools. Though it might take a while for running the duration of the compiling process might be a bit longer, but it will be possible. It's still possible.
So we can continue for the next 10, 15 minutes maybe,
Mhm.
and wait for more questions to come. If I'm alone in my institution for uh, just for an example, which criterion will be used to do my pairing? So, if you're the only participant from your institution, I highly encourage you to find at least two more folks who would be willing to go on a team with you, and make sure they register by tomorrow, ideally, so that we can make sure you at least have a team. Unfortunately, if there is not enough folks from your institutions, we might not be able to pair you with anyone. So that's going to be a challenge. So make sure you have at least two more folks because teams can be at minimum of three members, maximum of five members. So you need at least two more folks to join your team. So make sure you find those two people. And this is a competition for everybody. So no, you don't need even, any background on hardware design or AI to participate. So anybody can join. There's no limitation. Make sure the people who join, though, are in the same level of education as you. So if you're undergraduate, those additions need to be undergraduate students. If you're graduate students, those additions need to be graduate students. That's the only requirement in terms of teaming. But make sure to let your friends know to register by tomorrow before it closes so that we have all the names and all the information about your team and team members so that once we send out the confirmation, you know who's your teammates and you can start immediately. Wait for more folks to ask questions. I still see many people online. And if you're not online and attending this live, and if you have any questions that is not answered, feel free to send us a message on Discord once you're done watching this recording, and we'll be happy to answer those questions as well. The question came in, when will we get free access to our tools? So for open source tools, you have free access. You can start today. For Cadence Synopsys tools, once we are finalize the registrations, we'll be sending Cadence Synopsys with a list of verified users. So that means that you have to have a verified email for your institution, and Cadence Synopsys directly will get engaged with your institution to give you access to the tools for a limited time. And of course, it's going to be a limited number of tools that you have access, not every tool, but the tools that you have access to are going to be enough to complete this competition. The tutorials about Cadence tools and Synopsys tools, we'll have some videos that we'll be sharing, and we'll be relying on Cadence Synopsys to provide more training for participants to use their tool. However, we have covered the content on open source tools and free to use. So also for AI chatbot, you can use the free version. You can use any of the chatbots that you choose. There's many different versions out there. There's many different kind of chatbots that are out there you can use. I named a few. The ChatGPT, there's Claude Code, there's Gemini, there's Llama. Any la large language model that you're comfortable with, or you feel that it works best with for you and for your computer or for your design, feel free to use any of that. And just make sure that once you submit your designs, you have to have your prompts included. And yes, of course, the free versions have limitations. Um, and if you're interested to use more capability or get around those limitations, you can get the paid version. However, you don't need to pay to participate in this competition. You don't need to pay to win this competition, let me tell you this. The limitations are technically daily, so and this competition, the duration is long enough that we don't anticipate that it's going to be a problem.
I'd like to add something, Professor.
Yes.
Students right now across the globe can use Google AI Pro for 1 year for free. They have to just verify it through their institutional email ID. So I
That's
don't know.
amazing. Yes.
Mhm. Yes, I
I
just
forgot to
wanted to.
mention that. I appreciate that, Harish, to add that. So, as you heard, if you have a student ID, a username, an email, you can get up to a year of free use for Gemini Pro, which is the Google's large language model, and it's pretty good. So, I think that should answer your question. Thank you, Ashwin. So someone else is also saying that they saw Perplexity AI is free for a certain amount of time if you're a student. So that's great to hear. Yeah, so I mean, I'm 100% sure there's like trial versions that you can use, and there's so many different kinds of large language models that are free. Of course, there are different um, models available, and there's a lot of free models available you can use. The ones that I mentioned are not necessarily the only ones that are allowed. You can, as long as you provide the documentation, your prompts, and the output of the prompts, you can use any of the large language models you want. So the question is, I need to upload and insert prompt when we submit our project. So when you are committing your design phase submissions into GitHub and tagging it with design phase number, yes, that should include your prompts and the output of the prompt. If I give disclaimer instead of inserting prompt. I'm not sure if I understand your question. Can you clarify what you mean by that? Well, if you do not provide your prompts, we will not be able to evaluate your project. So prompts are a big part of your scoring rubric. So if you just give a disclaimer, you're missing out that big portion of the grade and the score that we need to see your prompts. Of course, to do any hardware design, you don't need AI, you don't need to prompt. So I can design a chip without using AI, right? So that's not the goal here. The purpose of this competition is to um, provide an opportunity for you to use AI tools and to design a chip. So the combination is what we are looking for. And that's why having your prompts as part of the submission is a big criteria. So if you do not include your prompts, you're going to miss points, which eventually is going to affect your ranking in the competition, and you won't win the prize. So I hope that clarifies. That is correct. So in conference journal paper, that's a different scenario. This is not a conference or a journal publication. This is a competition. And as part of the competition, it's a requirement for you to provide your prompts. So If you're not comfortable with that, then you won't include it. However, you're going to miss points. So it is really up to you if you want to include it and to get the points for it, or if you don't want to include it and you're going to miss the points. So it's really an option that you can choose. Okay. I think I don't see any other questions in the chat as of right now. And any um final thoughts from anybody in my team? Harish, Virmani, anything you guys want to add that I missed?
Nothing, Professor. I think we have all the information here. We are just waiting to see you guys come January 15th.
Yes,
And
so
happy
very
holidays,
excited.
guys.
Yeah, this is amazing. Thanks everybody again for joining us. We're very excited to see your submissions and can't wait to see what you guys come up with and see your final designs. And I'm rooting for all of you. I hope you're all successful in this competition and looking forward to seeing your designs. And if there's no other questions, feel free to leave us a comment or a note in the Discord channel. Make sure you let your friends know to register by tomorrow before the competition registration closes. And with that, I think it's safe to close this meeting. Thanks everybody again for joining and see you guys in January. Hope you guys have a wonderful holiday season and um, winter break. Thank you, everybody.